use a table to estimate the limit numerically. Well, I'll certainly have to use a table later, but I just showed you that trick, direct substitution. Let's try that because it's easy. If I use direct substitution, put a 0 in for x, that's going to be 0 over the square root of 1 minus 1, which is 0 over 0. I'm going to write IF here, capital I, capital F, because we call that an indeterminate form, which means we don't know what's going on in the graph at that spot. So if we get an indeterminate form, we have to go to plan B, which means one thing we can do is make a table and find out numerically what is the limit. There might still be a trend in y. If I graph these points, now I chose these x values that were close to 0. From the left, a little bit less than 0, and from the right, little bit greater than 0. Notice I didn't start at 10 and negative 10. I started at 0.01 and negative 0.1. And I got closer and closer, and I'm squeezing in on 0 from both sides. Look what happens as x is far away and to the left of 0, or less than 0, and far away and to the right, well, relatively far away. I get 1.994 and 2.00499 for y. As I move closer, look what happens to y. I go to 1.9994 and 2.0005. If I go a little bit closer to 0 in the x, I get 1.99995 and 2.00005. The question is, if I sent you to Las Vegas with $1,000 and I said, come back with $1 million for me, betting, what would you bet the value is there? Hopefully you would say, well, the trend in y, that's what the limit is. I'll write it again. The trend in y. As we squeeze the x, you can see y is going towards 2. For this particular graph, when I try to use direct substitution and I put in a 0 there and a 0 there, remember, I got this 0 over 0, which is an indeterminate form. That's not my limit. I know something funny was going on there. So I went to my table and I figured out, well, the trend in y is that y is going to 2. This is what a limit is. As we squeeze the x towards 0, there's x is 0. And we squeezed in, we said, what's happening to y? The y was heading this way, towards this value of 2. Notice there's a hole in the graph. Our limit is 2. Our limit is not 0 over 0. Our limit is 2. So does the limit exist? Yes, it's 2. Here's our second question. Is the limit reached? Of course, the answer is no. Why did I know the answer was no? Because I got 0 over 0 when I did direct substitution. That tells me right away that the limit is not reached. And when I graph it, I get a hole there. That's what it means to have the limit not reached. Oh, there's a trend in y. The limit exists because there is a trend in y, but the limit is not reached because we've got a hole there. It's just 2 bits of vocabulary. Does it exist? Is there a trend in y? Is it reached? Can we physically put a point there? The answer in this case is no. In more eloquent words, for this last problem, limit of x over square root of x plus 1, all minus 1, as x approaches 0, we saw that the limit did exist, even though the function was not defined at x equals 0. There was a hole there. This is often the case, and it's important to realize that, here it is, the existence or non-existence of f of x at c. That's, do you have an actual point, a y value, when x is this? Is there a point there or not? That has no bearing on the existence of the limit, the trend in y of f of x as x approaches c. In other words, if there's a point or if there's a hole there, doesn't matter. It does not matter. What matters is, can you figure out a trend in y? Meaning, if you went to Las Vegas, could you pick the number that y is going towards or trending towards?